Friends, my name is Sumit Mehta. So today we are starting a new chapter named as probability. Okay, and in the probability we will discuss about the conditional probability. Okay, so what is conditional probability, students? I'll write it as conditional probability. Okay, so the probability of the event E, let's say any event E is there, probability of any event E is called the conditional probability, is called the conditional probability of E given that event F, or you can say F, has already occurred. Okay, and it is denoted by P E given F, means probability of occurrence of E when F has already occurred. Okay, so let me give you one example. If E and F are two events associated with some sample space of a random experiment. Okay, so they are two events associated with a sample space. This is the sample space given. Okay, so probability of E given F will be given by probability of E intersection F upon probability of F. Okay, so students, this is the formula to find out the probability of E given F, which is also called as conditional probability. Okay, now let's discuss about properties of conditional probability. Okay, so now we will discuss about some of the properties of conditional probability. So property number 1 is P S given F is equals to P of F given F is equals to 1, where S denotes sample space and E and F are two events. Because let's say this is the example. Here S is sample space and E and F are two events. So let me give you the proof of this. So let's say PS given F. So as per the formula, that will be PS intersection F upon PF. So in the case of sample space where only two events are, so PS intersection F will be PF. Okay, so that will be PF upon PF, which is 1. Okay, and in case of PF given F is so simple, so it is PF intersection F upon PF, so that will be PF upon PF, probability of F upon probability of F, which is always 1. So students, now we'll discuss about the property number 2, which states that if A and B are two events of a sample space S, okay, and F is an event of S such that probability of finding f is not equals to 0, then we can say that probability of A union B given f will be probability of A given f plus probability of B given f minus probability of A intersection B given f. Okay, so this is the property number 2. So force this student to give the proof of this identity. Let me rewrite this as P of A union B given f. I can write this as P of A given f. Okay, if they are two disjoint sets. So condition is this should be disjoint. In case of disjoint sets, this quantity will be 0. Okay, so we were left with only this quantity. Okay, and by the case of distributive law, students, as all you know, PA given B is A union B is PA plus PB minus PA intersection B. Okay, so by using this identity, I can prove this. Okay, so I hope students now you're pretty clear about this identity, and we will use this identity in future to solve questions directly. Okay, so remember this identity by your heart. This is very much important. Now let's move to property number 3, which is also very much of importance. It states that probability of E dash given f, where E dash denotes the probability of not occurrence of E. I hope this you all must know, which is 1 minus PE. Okay, and probability of E dash given f is 1 minus probability of E given f. So this is very easy to remember, because as you all know that probability of not occurrence of E is 1 minus probability of occurrence of E. So students, in this class we have discussed about what is conditional probability and the 3 properties related to the conditional probability. And in the next lecture we will discuss about some questions based on conditional probability. So stay tuned for that lecture, students. Thank you. Happy learning.